Everybody, it's me, Miss You, and now we're going to be finishing with our quadrilaterals. We're going to start off. This obviously is a square. We want to find WV. Where is WV? WV, we want to find this diagonal. We know that ZY is 20, so that means W, where's V? So if I know that ZY is 20, that means all the sides are 20. I also know that these sides are all bisected and they're equal. So to figure out what this diagonal is, this is what it looks like. So I'm just going to draw it out here. I find it easier. 20, this is what we're looking for. We know that they're the same. We know that this is the hypotenuse. Oops, that's x. So we have two sides are the same. So I have x squared plus x squared is equal to 20 squared. 2x squared is equal to 400. Okay. X squared is equal to 200. And that means x is equal to the square root of 200, which is equal to 14.1. Okay, and that is our answer. Now, all the angles over here are either 90 or 45. Let's see, WZX. Where's WZX? W, start at W, go to Z, then I go to X. That is a 45-degree angle. So I'm going to go 13x minus 7 is equal to 45. I'm adding 7 to both sides. I have 13x is equal to 52, and x is equal to 4. When you divide 52 by 13, I get 4. And that is the answer. Now we're going to look at trapezoids. Trapezoid is another type of quadrilateral. Of course, the sum of the angles inside are 360. They only have one set of parallel bases. Okay? And the parallel sides are called bases. Oh, it says parallel lines. And the non-parallel sides are called legs. The legs are congruent. For an isosceles, this is an isosceles trapezoid. This is just a trapezoid. For an isosceles trapezoid, the legs are congruent. Okay? The diagonals are congruent. The base angles are congruent because I'm dealing with symmetry here. Those are my base angles. Okay. So these two are congruent and those two are congruent. Okay. And we're going to say opposite angles are supplementary. And lastly, I want to remind you with the mid-segment, this is mid-segment of a triangle, or this is actually mid-segment of a trapezoid. I'm going to say A plus C over 2 is equal to B. Okay, it is the average of the bases. Okay. So now let's look over here. This and G, those are the same, 117 degrees. And E, of course, 117 plus angle E is equal to 180. Okay, because they're, and that means it is 63. Okay. So here, the top and bottom, 10 plus 2x over 2 is equal to 12. I have 10 plus 2x is equal to 24. Okay. I multiplied both sides by 2, and now I'm going to subtract 10. 2x is equal to 14, x is equal to 7. Okay, there it is. This is to find the mid-segment. 27 plus 39 over 2. It's equal to 33. Excuse me. Achoo. Achoo. At least I have my voice back so I could do this. I was actually a little bit worried my ability to record this. Okay, and that's 33. Isosceles trapezoid. We know that the diagonals are congruent. So I'm going to say 9x minus 22 is equal to 4x plus 3. I have 5x. I subtracted 4 from both sides, and now I'm adding 22 is equal to 25. X is equal to 5. Okay? And I think this is the end of quadrilaterals. Yep. Let's turn the page. We're going to look at transformations. Okay. We're going to reflect along the line. X is equal to 2. So I like to draw the line x is equal to 2. I see it is 3 away, so I'm going to go 1, 2, 3, 1, 2, 3. And here I have, and this is what my reflection will look like. This is R prime, this is Q prime, and this is P prime. In case you forgot, we jump into the line of reflection, then we jump out of the line of reflection. Now we're going to reflect across y is equal to x. This is what the line y is equal to x looks like. Okay, and there we go. That's kind of what it looks like. We're going to count to the line, then down the line. So 1, 2, 1, 2. Okay. To count to the line, count down from the line. So now we're counting to the line 4, 8. So I'm going to go down 8. Okay. And this is R prime. And now last time, let's look at Q. We're counting to the line. That's 6. And we're going to go down 6. And that is my Q prime. And this is what my reflection across the line, y is equal to x, looks like. Okay. It is not a rotation, it's a reflection. Okay. And I want to point out that the numbers are the same for those. So now this is a translation. Okay, we're right 3, down 3. Okay, so I'm going to go right 3, down 3. Here's my 8 prime, right 3, down 3. This is my C prime, and right 3, down 3. This is my B prime. And this is what my reflection looks like. I am at 3, negative 3, negative, my y is negative 6 here, my y is negative 4 here. My x is 5, and my c over here, the x is 7. And those are my numbers. It's actually positive 5. I want to make sure it stays that way. Okay, now we're rotating. Okay, this is a rotation. Okay, 2 quadrants, reminder, x, y, at 180 degrees rotation becomes negative x, negative y. Okay, so A stays the same, B becomes This is -2, -3. 2, +2, it becomes -2, +3. That's B prime. C, it becomes -4, +1. -4, +1. And there we go. That is my 180-degree rotation. And of course, now we have a 90-degree rotation. I want to remind you, x, y becomes -y, x. X and y swap positions, and we adjust the signs. X and y swap and adjust. Okay, so let's look over here. X and y, 1, 1. This becomes 1. P becomes 1, 1. R, X and Y swap positions. So it becomes 4. So my X becomes Y, and I change the sign. 4. I adjust signs. There it is. And Q, of course, 1, 1, 4, 4. And this starts off as -4, 1, and it becomes 4, 1. 4, 1. All right? And that is rotating by 90 degrees. Okay? Ooh, that looks a little bit off. What did I do wrong? Oh, 4, 1 becomes 1, 4. That was my mistake. So 1, 4. This is how it's supposed to be. This is my Q prime. This is my R prime. And that's my P prime. And I'm going to outline it just so you're clear how it looks. Here we go. Okay. Now we're going to dilate using a scale factor of 1/4. Okay. Here I go. 1. I'm dividing all the 4s. This is 4. This is 4 by 4. So it's 0, 4, for example, goes times 1/4, becomes 0, 1. Okay? You want to multiply it, okay, by the scale factor. So this becomes 1. This becomes 0, 1. This becomes B over here becomes 1 minus 1.